Okay, welcome back. So we are headed into lesson 4, multiplying whole numbers and area. Remember whole numbers. We're still dealing with the chapter on whole numbers. So I'm not asking you to work with fractions or decimals or mixed numbers or anything of that sort, or negative numbers. So we're still staying in the land of whole numbers. Then we'll move on eventually. So multiplication is just repeated addition. I notice I had a misspell there. Is just repeated addition with a different notation. So 6 plus 6 plus 6 plus 6 is 24, but we can say that, and by the way, we can say 6.4, to indicate multiplication. We can say 6 times 4, or we can say like this, parenthesis 6, parenthesis 4. So there's different ways to express multiplication, but no matter what, you get 24. I want you to ask yourself what 8 times 7 is. It's 56, right? But if it takes you more than like a few seconds to realize what that is, then you probably don't have your times tables memorized. And I just strongly encourage you to maybe Google a multiplication table up to 12 by 12 and make sure that you have memorized up to 12 times 12 so that you can be on autopilot and be quick on your toes. Because when we head into algebra someday, right, and you find my beginning algebra course on iTunes, let's say, or my college algebra course, we're going to be factoring polynomials, and that is, excuse my French, but darn near impossible unless you have those multiplication tables memorized. There's lots of things that become very difficult, even just division without having the times tables memorized. So let's assume you know how to multiply. In fact, in my pre-algebra course, I go under the blanket assumption that you remember how to multiply and divide 2- and 3-digit numbers. But what you may be rusty on is the properties of multiplication and looking for keywords in a word problem. Well, just for kicks, let's go ahead without a calculator. Let's see if we can take 372 times 84. Now, depending on where you received your initial training, different people were trained to multiply in different ways. Here, we often say, we go this way. We say 2 times 4 is 8, and then I'll highlight it in another color. And then we go this way. And we say 7 times 4 is 28, but we record the 8, carry the 2. And then 3 times 4 is 12, plus that 2 is 14. Okay? And then we leave a placeholder. We put 0 here. We leave a placeholder. Why? Because we're going to now move in to the digit 8. And I'll just do this in another color. Now, we're going to say 8 times 2 is 16. Put the 6, carry the 1. 8 times 7, 56, plus 1 is 57. Carry the 5. 8 times 3 is 24. Plus that 5 is 29. And then we add. So 8, 4, 1. It's going to be 12, carry the 1. Carry the 1, and voila, 31,248, which is, you see I have a snapshot of the calculator there. So however you were trained, and I did want to, here's kind of cool, in some of the elementary schools today, they're even doing something called lattice method. Little note to self here on lattice method. There are other ways to multiply, so this is what they're doing. They're taking and making like a little rectangular table like this. It's kind of a cutesy way of multiplying. And we're going to draw diagonals, okay, in each one of these boxes here. And then what they're doing is they're saying, okay, 2 times 8 is 16. Record that. 7 times 8 is 56. Record that. 3 times 8 is 24. Record. And then like 2 times this here, 4 is 8, so we'll put 08 like that. 7 times 4 is 28, so we'll put 28. And 3 times 4 is 12, so we'll put 12. And now look at this cool thing. Here's this 8, record 8. Basically look on the diagonals. 8 plus 0 plus 6, well that's 14. Carry the 1. So 2 plus 2 is 4, plus 6 is 10, and then 11, 12. So put the 2, carry the 1. 1 plus 4 is 5, plus another 5 is 10, 11. Put the 1, carry the 1. And look at that. Look at that. 31,248. So that's kind of another cutesy way of multiplying. It just depends on your training. I did want to mention the ballpark estimate. Last lesson we talked about getting a ballpark estimate of the right answer using rounding and estimation. Well, think about it like this. Estimation is a great way to know that your answer is in the right ballpark, right? So if we estimate 372, and I'm just going to write here, go ahead and round that to the nearest 100. Well, that's awfully close to 400, right? And take 84 and round that to the nearest 100. Well, that's awfully close to 100. Oops. I just realized I meant don't round 84 to the nearest 100. Round it to the nearest 10. Okay, so 84 rounded to the nearest 10 will be 80, right? So mainly you're taking, two numbers that are now easier to multiply. So the question is, well, what's 400 times 80? Well, clearly that's 32,000. So what we're saying is that whatever the right answer is, it should be in the ballpark of 32,000. And if you look at what we got, well, hey, 31,248, it is arbitrarily close to 32,000. So we feel that we're not that, far off, and we feel that we've done it correctly. In other words, if I would have got, 58,000 or something, I know that's too far off of that ballpark estimate. All right, hope that helps. Now, let's review some properties of multiplication, namely everything that has a star on it, the properties of 0 and 1, the commutative property, the associative property, and the distributive property. I encourage you to devote these to heart. Multiplication property of 0. These are things you've known since you were little, but it's just that we're putting a name to them, and we're putting symbols to them. Anything times 0 is 0, and 0 times anything is 0, right? So the product of any number and 0 is 0. So 1,000,000 times 0 is 0. And look at this, a whole string of numbers, but you see that 0 is one of the factors. So we have many factors there, 4 times 5 times 8 times 0 times 3, but that's still going to come to be 0 because anything times 0 is 0. So devote that one. Devote multiplication property of 1, that anything times 1 is itself. That's sometimes called the multiplicative identity property, fancier name for it. So 7 times 1 is 7. That's something we've known that since we were little, and we're just calling it something, the identity property, or the multiplication property of 1. Now how about the commutative property? It says that order doesn't matter. Changing the order of two factors, keyword order, doesn't change their product. So we know that 6 times 3 is 18, but 3 times 6 is also 18. So I'm just kind of reading through these with you, and then again encouraging you to devote these to memory so that you could reproduce them on an exam or something like that. It also tells you what's a legal maneuver. I mean, order doesn't matter with multiplication, but it does matter with division, right? 6 divided by 3 and 3 divided by 6 will yield two totally different answers. So we're developing the legalities. What's a legal maneuver when you're operating on certain quantities? The associative property of multiplication, changing the grouping, keyword grouping, of factors does not change their product. So A, B, C, but notice here B and C are grouped together, and here A and B are grouped together. And then there's that illustration. In fact, I'll make that, I'll see if I can make that larger. Let's zoom in on that. Yep. See? 2 times 3, would make 6, and 5 times 6 is 30. But if you group the 5 and the 2 together and do that first, 5 times 2 is 10, but hey, times 3, you still get 30. So grouping does not change the product either. And so the associative property holds true for multiplication, but not for division and not for subtraction. And last but not least, so you see how I start all of these. That's all the ones we want to devote to memory. The distributive property of multiplication, that multiplication distributes over addition and subtraction. That's a way of saying we can distribute through the parentheses and say that 5 times 3 is 15. Hold the addition sign, keep it, and 5 times 4 is 20. So we can say that 15 plus 20 is 35, right? Now the neat thing is, if you chose not to use the distributive property and you chose just to go inside the parentheses first, notice 3 plus 4 is 7, but hey, 5 times 7 is also 35. So it just tells us that it's legal, that it's perfectly legal to distribute, okay? Over the operations is called over the operation of addition or subtraction. So I'll make a little side note. If you had 7 times 5 minus 2, it'd be perfectly legal, so a little example here, perfectly legal to say that that's 35 minus 14. Okay, legal to distribute the 7. All right, hope that helps. Now, last but not least, we have to review some key words for multiplication so that I keep noticing, sorry about that, I noticed a lot of misspells in my notes. Keywords for multiplication so that when we see a word problem, we know that it would involve multiplication. You might blatantly see the word multiply. Multiply 4 by 3, that's 4 times 3. You might see the word product. Find the product of 2 and 5. It's 2 times 5. You might see times, 7 times 6. Okay? But other key words might be per or area or of. So if I buy a rectangular area rug, see, here's my rectangular area rug, and the dimensions are 9 by 11. So we'll make this side 11. We'll make this side 9 feet. How much area in square feet will it cover? Well, you might be remembering area of a rectangle is length times width. So we're just going to take 11 times 9. And we're going to get 99 square feet. You can denote that feet squared like that. Okay? So be on the lookout for the word area. Also, what do I mean by the word of? Well, when we get to the chapter on fractions, we're going to see that a lot. We're not supposed to talk about fractions just yet, but 1/4 of 480 bucks is, so you can say that of means multiply. So 1/4 of 480. 480 is really over 1. When we get to the chapter on fractions, you'll see that when you're multiplying two fractions, you can travel straight across. So you can say that's 480 over 4. And 480 over 4 really means, hey, does 4 happen to go into 480 evenly? So 4 goes into itself once, and 4 goes into 480, 120 times. So 120 bucks would be the answer to that. 1/4 of $480 is 120 bucks. Okay? But notice the word of. 1/4 of, multiplying. Like I said, not supposed to talk about fractions just yet, so don't get worried about that, but know that that's coming. All right. So I didn't want this video to be too long. Those are our guided notes and our smart notes for multiplying whole numbers. And in the future, I hope to just upload more examples to the iTunes. Okay, good luck out there.